This video is going to go into simplifying roots. There's a few things that go into that, so we'll split it into two parts. We're mostly just going to focus on trying to break down square roots and then other types of roots as well. So first things first, what is a root? This is the square root of 9. Most people know this is equal to 3. Why is it equal to 3? Well, the square root usually means what number times itself gets you to this value. 3 multiplied by 3 would get you back to 9, so that means the root of that number is 3. Now, another way you could express that is 3 squared equals 9, so the square root kind of undoes the squared. Now, what we're going to need to understand throughout the year is that square roots can be expressed in various ways. Specifically, the square root of 9 can also be written as 9 raised to the 1/2 power. Roots are fractional powers, as strange as that might seem. An easy way to understand why that works is because if you picture 9 as 3 squared, 9 to the 1/2, if you actually use the exponent properties, you'd say 2 times a half equals 1. That equals 3 to the first, which is just 3. So a 1/2 power accomplishes the same effect as this square root symbol, where you ask yourself what times itself equals that number. So the other thing you got to understand is if you had a third root or so on, like the third root of 27, this is equal to something to the 1/3 power, and it means the same thing. Third root means what number times itself 3 times equals this. In this case, it'd be 3 to the third. So 3 to the third raised to the 1/3 will get you back down to 3. So just keep in mind as we go through this that roots are simply fractional powers. Now let's actually try to simplify a couple of these. We've got the square root of 32. Square root of 32 is not a whole number. You could say, well, square root of 25 is 5, and square root of 36 is 6, so it's somewhere in between these two values, probably like 5.5 or something, but it's not quite a whole number. So all we can do with this is try to break it down into other numbers that go into this, which might be square rootable. Now, an easy way to understand why that works is to go back to the exponents again. So picture this as 32 to the 1/2. If you have a power on something, that could have been a group to that power. So you can picture doing this as 16 times 2. As long as both of these are still affected by that, you can write it this way, and you can bring the power to both items. So 16 to 1/2 times 2 to the 1/2. All I'm really doing here is attempting to break the 32 into square rootable values. So instead of writing it this way, this is kind of silly, I'm just showing you why it works. You could just say, well, that's the square root of 16 multiplied by the square root of 2. The square root of 16 is just solid 4. The square root of 2 is good as it is. So this is what you're trying to get towards. This is why it works, but this is what you're trying to accomplish. You want to look at the 32 and break down any perfect squares that are inside of it. Now, had you not noticed that 16 goes into that, that's okay. Had you maybe done 4 instead, that's totally fine. So square root of 4 and square root of 8, that's just 2 square roots of 8. Just don't stop here, keep going. This is another 4 and a 2, so this is 2 times the square root of 2. You'll get to the same answer. This is still 4 square roots of 2. Alright, so the idea here again is you're trying to take this number and break it into smaller parts, take out any perfect squares that you can. If you had a third root, again we talked about this before, you're looking for values that go into this 3 times. So same idea applies. What you're really doing is this is a 1/3 power, it applies to each of these, but you can think of it as just multiples. So 24, if you fully break it down, is 2 times 2 times 2 times 3, or 8 times 3. 8 is able to be third rooted because it's 3 2's. So the third root of 8, the third root of 3, you could just write that as 2. Unfortunately, the third root of 3 will still be trapped. Now, x to the 5th, there's a bunch of x's there. If you actually wrote them all out, it might help you see it better, but you want groups of 3, because any group of 3 can be third rooted evenly without issue. So one of these can be broken out, the 2 of these unfortunately will still be trapped. So this one will come out as normal x, that'll be sitting outside of here. This 3 will still have an x squared on it. So there's nothing else we could do with this. This third root is trying to go on the 3, it won't be a nice number. There's only 2 x's left, there's not enough to make a full set. Let's try a few more examples. So we're at 40, we're again looking for numbers that go into this. 4 and 10 are the best way to break that one down. Square root of 4 is just 2, square root of 10 can't be done. We know we're finished because all you could do with 10 is 2 and 5, and neither one of those are perfect squares. These are both prime numbers. There's no other values in 10 that we can use, so this is as far as we can go. With 54, it's a third root, so watch out for that. We do have to be careful not to take out pairs. We have to do groups of 3 now. 54 is 27 times 2, and so 27 third rooted is just 3, and we can't do anything with the 2. The square root here, there's a lot of stuff going on with this one. I usually just break this down into numbers, x's, y's, just go one group at a time. So the 98 is going to be 49 times 2. The x third we can come back to in a little bit. The y6 will come back to in a little bit. This will just be 7 and square root of 2. So x to the third, let's go back to that. We do have a pair of x's with 1 left over. So we can square root this and put that on the outside. We cannot do anything with that, so leave that. The y6, that's actually 3 solid pairs of y squareds. So we can actually square root all of those nicely, and we'll get a solid y to the third. And another way to think about that is y6 raised to the 1/2. That should just be multiply those powers together and get y to the third anyway. So a couple ways to think about that. If you actually broke it down one at a time, you get there anyway. The best final answer here that we could put is the 7's outside, the x is outside, this y third is outside, and there's a couple more things left inside of the square root 2, and x are still on the inside. So that's all we're left with here. I've kind of run out of room for this last one here, but we'll try to squeeze it in. 24 is one we saw before. This is 8 times 3, so the 8 can be done. Now you might think a negative inside of the square root is a problem, but this isn't a square root, so a negative is okay inside of a third. You can still get a negative number inside of there. The negative 2 to the third multiplied by 3 is essentially what we have there. X to the 7th, there's a couple x thirds inside of that, so we can take the roots of all of those. In the end, your final answer will be negative 2 comes out. A couple of those x's will be free now. This one becomes x, so does that. And then stuck inside is still a 3 and an x.